Morning. Today we are going to discuss or explaining the radar applications and the frequency in the subject radar and TV engineering. In the radar and TV engineering, we are going to study about the radar. In this subject, we will discuss the radar operation, construction, block diagram of radar, applications, frequencies, type of the radars, and different concept of the radar. So in this lecture, we will go to understand the applications and the frequencies of radar bands. To learn the radar fundamentals, operating frequencies, and the applications, to understand the basic concept of different type of the radars are surveillance, which is used in the radar system. So today we are going to understand the basic concept of the frequency spectrum, which is used for different type of the radars, and we are going to understand the concept of the frequency and application of the radar. Now, introduction about the radars, radar frequencies, and radar applications are the content of this video lecture. The textbooks for this video lectures is Introduction to the Radar System by M.I. Skolnick, Tata McGraw-Hill, special Indian edition. You just go through with this Indian edition because this book is a very good book to understand the basic concept of the radar as well as the applications as the frequency. Introduction reference books are the Introduction to the Radar Systems, Merrill I. Skolnick, third edition, Tata McGraw-Hill, 2001. Radar Principles and Technology, Application, Baron Ed Pearson Education. Principle of the Modern Radar, that is the basic principle by Mark A. Richards, James Pesce, William A. Hole, is the 2013. Radar Handbook by M.I. Skolnick, second edition, Tata McGraw-Hill. Understanding the radar system by the Simon Pixley and McGraw-Hill. The outcomes of this lecture is that the student will understand the concept of the radar frequencies. They are also able to learn the different application of radar. They will understand the applications according to the frequencies and the application according to the user applications. Or human beings are able to detect the target in the surveillance as well as in the case of our society. If you are want to detect any object or any things, any valuable object, so drone type of radar is applicable for that. So radar is the contradiction of the words radio detection and ranging. It is primarily a detection tool. The major source of the detection mechanism is the radio waves. So radio wave is the mechanism in the detection of the target in the case of radio wave detection, and in the radar system. Radar is an electromagnetic systems for the detection and the location of the object. They are able to find the object using the radio waves, and the backbone of this radar is the radio waves. It operates by the transmitting a particular type of the waveform, a pulse modulated sine wave example, and detects the nature of the signal. Now we have radar frequencies. The conventional radars are the operated at the frequencies extending from 220 megahertz to the 35 megahertz, a spread of more than 7 octaves. Means radar is applicable for the 220 megahertz to 35 megahertz. That is the lower limit of radar working frequency is the 220 megahertz, and the upper limit of the radar working frequency is the 35 gigahertz. So the in this span, the radar, all the type of the radar is work. Beyond this frequency, radar is also applicable to work, and if you want to design for high frequency about 35 gigahertz, so you are allowed to design that type of the radars. They are able to work for very high frequencies. These are not necessarily the limits, since the radar can be and have been operated at the frequencies outside either end of the range. So there is no limitation to the radar to work in this particular frequency band. They are able to work in beyond of this frequency because of all electromagnetic spectrum is based on the radio wave frequency. Particularly, radar has some designations for designation band for particular applications. So these band will be further discussed in the next coming slides. The place of the radar frequencies in the electromagnetic spectrum is shown in the figure below. Some of the nomenclature employed to designate the various frequencies region is also shown in this figure. This is the frequency band or electromagnetic spectrum represented by the radio waves or electromagnetic spectrum, which is consisting the frequency versus the wavelength graph. In this, we have the frequency as well as the wavelength. So frequency scale is divided from 30 hertz to the 3000 gigahertz. So starting range is 30 hertz, and it is from 300 hertz, and next is 3 kilohertz. After that we have 30 kilohertz. Then next range is 300 kilohertz. Next 3 megahertz. Then we have a 30 megahertz. Then we have 300 megahertz, 3 gigahertz, 30 gigahertz, and 300 gigahertz, and up to 3000 gigahertz. So this is the complete frequency range of electromagnetic spectrum. So this frequency range is divided into the audio frequency band, radio frequency bands, video frequency band, microwave regions, or radar frequency bands. Now the wavelength is the inversely proportional to the frequencies, that is the starting from 10 kilometer to the 0.1 nanometers. So 10 kilometers to the 1 kilometer frequency wavelength range is known as kilometric wave, and it comes into the band number 5. Below 10 kilometers, we have a very low frequency band, that is the microlometric waves, and known as band number 4. So 1 kilometer to 100 meter is known as the hectometric waves, and band number 6, it is known as a medium frequency band. 100 meter to the 10 meter is known as the high frequency band, that is HF, decometric waves, and band number 7. It is also known as OTH radar. Next frequency band is the VHF, that is the very high frequency band, and metric waves. It is known as the band number 8. So from the band number 8 to band number 11, we have radar frequency band, and it is also known as a microwave window. After that, we have a 1 milli to 10 centimeter band, that is the ultra high frequency band, and it is worked as a decimetric waves and band number 9. Next, we have the super high frequency band, that is the work for a centimetric wave, that is band number 10. And after SHF, we have extreme high frequency band, which is having the wavelength from 1 centimeter to the 1 millimeter, and millimeter waves are known as a in this particular band, and band number 11 is the designation for that band. In the last, we have in the electromagnetic spectrum 1 millimeter to the 0.1 centimeter band, that is for decimillimetric waves, band number 12, and it is known as a sub-millimeter waves. So this electromagnetic spectrum shows that the frequency bandwidth and frequency range in the particular band, as well as in the same band correspondingly, the wavelength is also given in this electromagnetic spectrum. So radar frequency band has some specific designation, that is the L band, S band, C band, X band, KU band, and Ka band. So these are the microwave region, and these bands are known as the specific radar bands. Now we have letter designation codes, code designation for the radar frequencies. Particularly, some band is assigned by the or code is assigned by the military for purpose of the secrecy. So in the development of the radar, its letter code such as the S, X, L, etc. was employed to designate the radar frequency bands. In the previous slide, in the electromagnetic spectrum, we have already discussed the L, S, C, X, KU, and Ka band. This is the microwave region window band, and it is also known as the radar frequencies. So these bands are specifically designed or specifically assigned for application of the radars. Although its original purpose was to guard the military secrecy. So this type of the band is purpose to assign the military secrecy, and it is applicable for only the military. The designations were maintained probably out of the habit, as well as the need for some convenient short nomenclature. This use has the continued and is now an accepted practice of the radar engineers. The table below lists the radar frequency ladder band nomenclature adopted by the IEEE. These are related to the specific bands assigned by the International Telecommunication Union for radar. Previously, we have discussed the L, S, X, and KU band. These bands are especially designed for radars, and this is the nomenclature adopted by the IEEE and the ITU units, or International Telecommunication Union for radar. So these two international governing body is specify the band for radar. They have assigned the code to the particular frequency band for the application of radar. For example, although the nominal frequency range for L band is the 1000 to 2000 megahertz, a L band radar is thought of as being confined within the region from 1215 to the 1400 megahertz, since that is the extent of the assigned band. So L band has a nominal frequency range is the 1000 to 2000 megahertz, and the for particular radar application, this type of the band has the frequency range from 1215 to the 1400 megahertz. This particular table shows that the standard radar frequencies, latter band and nomenclature. In the table first, we have the band designation. Table second shows the nominal frequency range. Table third shows the specific radio location band based on the ITU assignment for region 2. For a particular region, region 2 is a specific region by ITU. So first is the HF band, that is the high frequency band. It's have a nominal frequency range from 3 to 30 megahertz. VHF band, very high frequency band, that is having the nominal frequency range is 30 to 300 megahertz. It is given in the frequency spectrum or electromagnetic spectrum uh, in the frequency table or frequency graph scale. So radar has a some specific band in the case of the VHFs, that is the 138 to 144 megahertz, and second is the 216 to 225 megahertz. Ultra high frequency is having a nominal frequency range from 300 to the 1000 megahertz, and 420 to 450 megahertz, and 890 to 942 megahertz. L band has the 1000 to 2000 megahertz, and it has a specific radar band is the 1215 to the 1400 megahertz, and S band has the frequency range for nominal frequency range, that is the 2000 to 4000 megahertz, and it has a specific radar frequency band. It's 2300 to the 2500 megahertz, and 2700 to the 3700 megahertz. Similar C band designation is given as a C, and nominal frequency range is the 4000 to the 8000 megahertz, and specific radio locations is the 5250 5925 megahertz. X band is the 8000 to the 12000 megahertz, and it has a radar band that is the 8500 to the 10650 megahertz. KU band stands for the 12 to 18 gigahertz, and 13.4 to the 14 gigahertz is the band for the KU, and 15.7 to the 17.7 is the another band in the case of the radar bands by ITU. K band has a nominal frequency 18 to 27 gigahertz, and for case of the radar specific band 24 to 0.5 to 24.25 gigahertz for the K band. Ka band has a nominal frequency that is the 27 to 40 gigahertz, and specific radar frequency band is the 33.4 to 36 gigahertz. Next and last, we have the millimeter wave frequency band, that is the 40 to 300 gigahertz. Now we have the application of the radar. In application respect, we have a wide range of the application of the radar. So radar is also applicable in the military sections, industrial applications. They are able to find the application in the automobile sections, and it is also able to understand give the application in the airport authority system or air traffic control systems, as well as they are having a civilian applications, and they have also in the field of the education. So these are the different application of the radar. So military use is the initial and important user of the radar. Military or defense is the very initial and important user of radar, because the development of radar is was from the military or defense. Early warning of intruding enemy aircrafts and missiles. They are able to find the enemy aircrafts and the missiles, tracking hostile targets, and providing the location information to the air defense system, consisting of the tracking radars, controlling guns and missiles. Tracking the hostile targets and the providing the location information to the air defense systems, consisting of the tracking the radar, controlling the guns and the missile. They are able to track the target or enemy information. They are able to find the information of the enemy, location of the enemy. They are able to find the distance of the enemy from the base point or military camps, and they are able to track the uh, uh, guns and missiles of the enemy. Radars is able to battle surveillance and the information of it. Is the also able to find the information, coded information of the enemy, navigation of the ships and aircrafts, helicopter, etc. They are also able to navigate the ships, aircrafts, and the helicopter of the enemies or other parties. Next application of the radar is the civilian use. This is the most important application in the case of the civilian area. And another application is the air traffic controller, ATC. It is work as a air traffic controller, through which we are able to control the air traffic. The all airports are equipped with the ATC, that is the air traffic controller radars, for the safe landing and the takeoff and guiding of the aircraft in the bad weather and the poor visibility conditions. So this is the advantage of the our radar system to guide the aircraft in the bad weather conditions and the poor visibility conditions. They are able to control the landing and the takeoff the flights or aircraft. So the radar system is a very good system for the air traffic controller or airport system. So next application in the civilian applications, we have the aircraft navigations. All aircraft fitted with the weather avoidance radars. These radars give the warning information to the pilot about the storms, snow perceptions, etc., laying ahead of aircraft's path. So next is the aircraft navigation, so that it is able to find the weather condition, and they are avoid the to take off or landing the flights in the case of the unavoidable weathers. So because of the radar, because radar is a system which gives the about the information about the storm, snow, and perception, etc. So radar is used an altimeter to indicate the height of the aircrafts and the helicopter. This is the another application of the radar through which we are able to find the altimeter of the target or height of the aircraft from the ground. Apart of this, there is the one more application that is the police controlling the traffic by the radar. They are eligible to find the speed of the vehicle at the route. They are controlling the accident through the high speed vehicles. So this is the one more application in the civilian use. Next application is the maritime ships safety and navigation. So this is the application in which the radar used to avoid the collision of the ships during the poor visibility conditions, storms, cyclones, etc. In the marine, this type of the radar is used to control the collision or accident of the ships or our small type of the ship or boats to during the poor visibility condition and a storm and cyclone. So this type of the radar is to avoid the collision and it gives the safety to the ships, guide the ship into the seaports safely. This type of the radars is generally used to guide the ships into the seaport safely. They provide the safe and easy way to reach at the port without any difficulty and harms to the ship or human being. So next application is the meteorological radars used for the weather warning and the forecasting. Provides the sufficient advance and information to the civilian administration for evacuation of the population in the times of cyclone and storms. So this type of the application is based on the civilian applications. Human being will be the getting the safe by the thunderstorms and the cyclones and other weather related problems. So this type of meteorological information is provided by the some meteorological type of radars. Apart of these, radar is also able to find the depth of ice and they are able to find the course area of the Ganga or the river. They are able to find the depth of the water in the river from the distant point. So this is the main application of radar. Now we have a types of the radars output display. We have already discussed the PPI type and the A scan and B scan type of display. Now we are discussing completely types of the radar output display. A scan type display used for a gunfire control and accurate range information. A-type scanner is a receiver system which gives the display in accurate range. B-scan is the another type of the radar output displays used for airborne fire control, range and the bearing forward looking. E-scan type is used for the measurement of the altitude. PPI type output display shows that the use for the surface search and navigation. So this type of the display is very good for the navigation and the search. Next, we have the specific types of the radars. The frequency modulated continuous wave radar used for the radar altimeters and the missile guidance. So FMCW radar is used for the radar altimeter. It is used to find the height of the object, and it is used for missile guidance. Pulse Doppler radars, another type of the radar is the pulse Doppler radar. We have already discussed the block diagram of the pulse type of radar. So the carrier wave frequency within the pulse is compared with a reference signal to detect the moving target. So pulse Doppler radar is generally used for the moving target. So in the police control room, this type of generally radar is used to control the vehicle speed. Another type of the radar is the moving target indicator radar, that is the MTI type of radars. Signals compared with the previous return to enhance the moving targets. Such radars. Frequency agile systems, that is the last and another type of the radars, and difficult to jam. So MTI radar is generally used as a search radars. And next we have SAR and ISAR, that is systematic absorption radar, and phase array ASIS or phase array radar, that is the essentially 360-degree coverage. This type of the radar is covers the 360-degree covering, and phase shift and the frequency shift allow the planar array to steer the beam. Also allows the for high and the low power output depending on the requirements. This is the radar system, given that the how the radar is work. So this figure shows that the how the signal is transmitted from the transmitted antenna, and how the signal is received by the receiver antenna. Same type of the antenna is used as a transmitter and receiver because of that duplexer. Duplexer is a device which is a switching device which switch in between of transmission and reception of the antenna. So here we have using the parabolic dish type of antenna, and it transmits the signal to the aircraft or a moving object, and the signal is intercepted by the target, and some of the signal is reflected back to the antenna, and some of the signal is reflected to the another direction. So this type of the signal which is reflected in the another direction is known as the wasted echoes, and those who comes to the radar antenna and intercepted or received by the system is known as echo signal or received signal. So this is the all about the radar system basic concept and basic phenomena of the radar system. After that, we have is some solved problem related to the radar systems. A certain radar has pulse repetition frequency of 1250 pulses per second. What is the maximum unambiguous range? MUR. The maximum unambiguous range is given by the solution, is given that the formula related to the maximum unambiguous range, that is the RUM equal to the C upon 2FP, where the C is the speed of the light and FP is the pulse repetition frequency. So maximum unambiguous range is equal to the 3 into 10 to the power 8 upon 2 into 1250 meters, and 120 into 10 to the power 3 meters equal to the 120 kilometers. So this is the maximum unambiguous range for the radar. Second solved problem is related to the shipboard radars. In the shipboard radar has the 1 microsecond transmitted pulse. Two small boats in the same direction are separated in the range by 100 meters. Will radar detect the two boats as a two target? The solution of the above problem is given under this presentation, that the radar range resolution, it is the very important conceptual problem related to the radar range resolution. The radar range resolution of a radar is its ability to distinguish the two closely spaced targets along the same line of the sight. The range resolution is a function of the pulse length, where the pulse length is equal to the LP equal to the C into tau upon 2. So two-way range corresponding the pulse wave, the radar range resolution is solved given by or solved by the given formula, that is the LP is equal to the C into tau, and C is the 3 into 10 to the power 8. It is the speed of the light, and tau is given that 1 microseconds. So 1 into 10 to the power minus 6 and upon 2. 2 is used for two-way range corresponding to the pulse width. So it is divided into the half, or divided by the 2, because two-way communication. So we are getting the radar range resolution is the 150 meters. So resolution is ability of the shipboard radar is 150 meters. Now in the next section we see that the radar is able to detect the target as a two target or a single target. Since the boats are at 100 meters apart, which is the less than the range resolution of the 150 meters, the radar cannot detect the two boats as a separate target, because the we have the resolution range is the 150 meters, but the radar shipboard has the two boats at apart 100 meters. So the radar cannot detect two boats as a two separate target. Understand? This problem is related to the radar resolution. Such type of the problem is discussed in a previous lectures also. So next we have discussed again this type of the problem with changing some conceptual values and some conceptual phenomena. Now we have some multiple choice questions related to the today's lecture, and this multiple choice question is based on the radar concept, radar frequencies, and radar applications, and the types of the radar and display. What device is located between the magnetron and the mixture and prevents the received signal from entering the magnetron? We have already discussed this type of the device. So choice is the A, TR box, B is ATR box, C, RF attenuator, D, resonant cavity. So correct answer is ATR box. Where is the RF attenuator used in a radar unit? A, between the antenna and the receiver. B, between the magnetron and the receiver antenna. C, between the magnetron and the AFC section of the receiver, between the AFC section and klystron. So answer C. The number of the pattern radiation pattern required to specify the characteristics are 3, 4, 2, 5. The beam width of the antenna pattern measured at the half power points is called half power beam width, full null beam width, none of the mentioned. What radar circuits determine the pulse repetition rate? A. Discriminators. B. Timer or synchronizer circuits. C. Artificial transmission line. D. Pulse rate indicator circuit. Answer B is timer or synchronizer circuit. Sixth, given the pulse width of 8 microseconds and a duty cycle of 8%, determine the pulse repetition time of a radar system. A 100 microsecond, B 1 microsecond, C 1000 microseconds, D 10 microseconds. So correct answer for that is 100 microseconds. Patch antennas are the antenna for small size and are made of A. Strip line, B. Microstrip line, C. Coaxial cables, D. Rectangular waveguide. This problem is related to the microstrip patch antenna. You have to understand that the construction and the working of the microstrip patch antenna in the subject of antenna and wave propagation. Question number 8 shows that the range markers are determined by A. CRT, B. Magnetron, C. Timer, D. Video amplifier. So answer is C. Correct answer is C. Timer is range marker are determined by timer. Question number 9, the characteristics of the magnetron output pulse that relates to accurate range measurement is its A. Amplitude, B. Decay time, C. Rise time, D. Duration. Answer is C. Correct answer is C. Rise time. Question number 10 is circuit to develop the audio frequency circuit voltage in a radar receiver is called A. Peak detector, B. Crystal mixture, C. Second detector, D. Discriminator. Answer is D. Discriminator. So today's lecture conclusion is that today we have studied about the radar frequency bands specifically designed by ITU and IEEE and military bands. We have also discussed the electromagnetic spectrum through which we are able to understand the nomenclature of the radar frequency band and nominal frequency of radar. In the next section, we have discussed the application of the radars, different application. What are the applications? Civilian application, military application, maritime applications, automobile type applications, and we have the number of the applications for the radars. Radar system is applicable in the worldwide as a system which is used to find the blind objective. They are able to find the object at the distance through this radar system. In the next section, we have seen that the different type of the receiver output display through which we are able to find the different applications, searching application, altimeter applications. And next section, we have discussed the about the type of the radars. In that type, we have discussed the FMCW radar, pulse type radars, MTI type radars, and further we have a phase array radar. So these are the radars which is working as a different applications, different aspects, and different uses. So this is the all about the radar frequency and radar applications and types of the radars. So student will able to learn after this lecture. Watching this lecture, they are able to understand the frequency spectrum of radars and the microwave region and radar frequency designation governed by the or given by the ITU and IEEE societies. They are also able to understand the application of the radars. So thank you for watching this video.